Today, we're going to talk about building contextual retrieval with Anthropic and Pinecone. I'm Arjun from Pinecone. I'm a developer advocate here. All I think about every day is how to teach people to use vector databases in their Retreival Augmented Generation applications. And I'm here with Alex from Anthropic. Hey, Alex.
Yeah, hey everybody. Super excited to be here. I'm Alex. I lead developer relations at Anthropic. So basically, I just get to talk about Claude all day and every day.
I can't imagine a better job. That's awesome.
It's a lot of fun.
Let's hop into the agenda. So first, we'll introduce what RAG is and where it works well and where it doesn't. Next, we're going to talk about a specific case study in which you could apply retrieval augmented generation techniques in the context of video presentations. We'll talk about the benefits and strengths of this approach and how we can introduce contextual retrieval in order to make a robust RAG chatbot over video data using Pinecone, Anthropic, and AWS. We're not going to have this webinar without showing you a live demo, so we'll show you what's going on and how this works inside of a SageMaker notebook. And finally, we'll have Q&A, so you can ask us about anything you'd like to learn about contextual retrieval, the demo, applying Pinecone or Anthropic, so on and so forth. We're hoping to allocate at least 20 or 30 minutes to Q&A time. So if you have questions while we're working through the presentation, please drop them in the Q&A, and we should have ample time to answer all of them. All right, let's get into it. So just to level set, what is the goal of retrieval augmented generation? Why do people even bother implementing this type of workflow in the first place? The idea is to increase the quality and the accuracy of any response that is being generated from an LLM that you're using, specifically tied to a knowledge base. And the way you increase the accuracy or the quality of that response is by giving the LLM the semantically relevant content it needs to generate an appropriate answer. Why does that matter? When you use an LLM without any context, especially without the context of your proprietary data stores, like knowledge at your company or data that isn't publicly available on the internet, it is not going to be able to answer it with the knowledge that it's been trained on. So you might be more prone to creating hallucinations. The standard way of solving this is giving your LLM access to a knowledge base in order for it to answer questions and reason over this type of data. The workflow for this must be familiar for many of you on the call. It's a standard retrieval augmented generation workflow where you have your source data, your embedding model, which is going to represent the source data in a vector space. You might upsert that into a vector database, preferably with Pinecone. You would have that query against the chatbot application with respect to the answer, pass all of that retrieved context to the LLM, and finally generate your answer, which allows your LLM to ground its generations with regard to whatever question you're using. This is a pretty robust workflow. You can use this to answer lots of questions that are hard to answer normally without access to an internal knowledge base, especially with company data like customer support or specific verticals like medical, financial, so on and so forth. But what if the type of data you're asking over is more complicated than just text-only data? What can you do in that situation? So let's take a look at let's take a look at the video data, for example. So if you're thinking about video data, you might run into a problem where the modalities that you're working with are in lots of different spaces. So if you're working with video data, you might have audio, you might have video, and you'll have slides. And it's not necessarily intuitive how to figure out how to embed all of these in the same vector space. Or if you were to use a multimodal model, it could be extremely expensive to represent all of these ideas in the same vector space. Additionally, when you're working with video data, you might have a lot of context that you need for the chunks that you're trying to process. You might have videos that are hours long, and some segment within the middle of the video might matter to something that happens near the end of the video, but the LLM that you're working with might not be able to transform and use all of that context. Finally, there might be a discrepancy between the visual information of the video and the spoken information of that video. You might have something on screen that the speaker is not actively addressing, yet you might want to be able to query both of those ideas at the same time. So the methodology in which you're going to use to process this data must have this in mind. One of the possible solutions we can use to kind of solve this problem is using Pinecone, Claude, and AWS to ingest and describe the video data into image and text pairs, and then perform retrieval augmented generation over them. And today we're going to show you how you can do this with Pinecone, Claude, and AWS. But before we jump into what that actually looks like, I'm going to give you a real-world example of what this could be. This is a slide from a presentation that I gave that's publicly available on Pinecone's YouTube. Everybody, why don't you take a moment and try to guess what I'm talking about with this slide on screen. So put in the chat, like maybe one sentence of what you think I'm trying to answer or what question I'm talking about with what's on screen right now. Take a second, think about it. If you don't want to write it into chat, that's completely fine. For those that might not be looking at the screen, on the slide, we see a table with a pro and con chart, and we see full text search and multilingual semantic search and the pros and cons of each approach. Cool, we have some answers coming in. It could be about hybrid search, getting the correct context. What is the need for hybrid search? Great responses. Okay, now I'm gonna try to introduce a little more context. So now, instead of just having the slide on the screen, we have the transcript. So this is what I said while this slide was on screen. I'm gonna take another moment or two for everybody to kind of read over that transcript, kind of guess like, what was I talking about? What was I trying to get at this point in time? Throw your answers into the chat or just think about what you think is happening here. Fun fact, in one of my past jobs, I worked on speech recognition models. And so a lot of my job was to sit and read transcripts from transcribed data. And it's actually really difficult to understand what is going on from a video or from some audio based on the information that has been transcribed. Okay, let's go a little more. I'm going to give you the full summary of what has been said in the entirety of the video. And now the picture kind of becomes a little clearer. So what happened during this slide is I was actually referring to the slide after having presented it. So I was no longer really talking about full text search or multilingual semantic search, but I was talking about how difficult it is for multilingual models to handle cultural nuances, specifically in the context of weddings. And this presentation was actually about multilingual semantic search in general. So we had gotten to a point where we were talking about how multilingual semantic search might work, where it might doesn't, and specifically where multilingual semantic search might fail. So now you might be able to appreciate why it's important to have these three different pieces of context when you're trying to create a representation of what is happening at this point in time in the presentation. Great, so how do we actually go about incorporating this information and how are we using our stack? We're going to use Pinecone as our vector database, which is going to be our knowledge base, the place where we put our metadata, and the place where we do our semantic search for that first part of the RAG workflow. Secondly, we're going to use Claude, which is going to be our state-of-the-art LLM. It has visual understanding, which will help us pre-process the data. It's going to be our key generating LLM, which is going to help us create that final response in the RAG workflow. And it'll create the context that's needed to embed the data that we need in a contextual manner. Finally, we're going to use AWS as the place where we store our compute and our data. We're going to use also AWS for Titan embeddings, our way of accessing Claude via Bedrock, and as our dev environment using SageMaker notebooks. And yes, our data set for this demo is going to be this webinar that I gave recently, Magic of Multilingual Search, which covers a whole bunch of different concepts from zero to building a multilingual semantic search application. We're going to build a RAG solution that allows us to answer questions about the slides, the audio, and what is being said and shown over this video. So first, why should you use Pinecone when you're building this sort of stack? Pinecone is a vector database that lets you index vectors to do this fast semantic search at scale. So you'll have your import query. You want to embed that query in some vector space that's going to be the same as all the documents that you've represented already. And Pinecone lets you do this extremely quickly at scale. What's nice about Pinecone is that it has a great developer experience, and you don't have to think about how to provision resources when you scale up your data. So you can imagine when you go from one video to tens of hundreds of videos to an entire YouTube channel, you won't have to think about providing more resources because Pinecone is inherently serverless. We also have a lot of integrations with popular data sources and frameworks like LangChain and Llama Index, so we can be where you are already. Pinecone serverless is great because, like I said, you don't have to provision any resources. You can just scale up or scale down your usage, and you can use your usage independently with your compute and your storage costs being charged separately. So it only scales up as much as you're using it. Enough about Pinecone. Let's talk about Anthropic and Claude. Alex, why don't you take it away?
Thanks, Arjun. Yeah, hello, everybody again. I want to just start by kind of laying the foundation for how we think about what we're building at Anthropic and about Claude more generally. I always like to stress this to developers that it is our goal to always be on the frontier of model capabilities. And this has been proven already multiple times this year in just 2024 alone. This graph was back from our initial launch of Claude 3.5 Sonnet, so we need to update it a bit. But as you can see here, we've already built the world's best LLM twice in 2024, and I guess 3 times technically if you count the latest Sonnet release, which I'll get into. Next slide here. So what did we just launch? So if you've been paying attention to the AI news, you might have just saw that we had a big October launch where we actually released a new and upgraded version of the Claude 3.5 Sonnet model. So the new 3.5 Sonnet model is better than the old 3.5 Sonnet model in a multitude of ways. As you can see in just some of these benchmarks here, we got the GPQA score went from 59.4 to 65. MMLU Pro bumped up by 3%, coding bumped up by a large percent, and a lot of these other sort of agentic actions also increased a lot as we upgraded this version between the models. Next slide, please. And that's really the most important takeaway here that I think I really want to get through is we're making this transition from models that do single action chains to models that can now plan on long time horizons. So as you can see in this chart here, we have categorized models now in terms of how they can perform versus a human with time limits. The new 3.5 Sonnet is by far and away the best model that we've seen across the industry in terms of matching human performance. So now we're starting to exceed that 30-minute time mark as measured by this organization called Meter, which does model evaluation and threat research. So now 3.5 Sonnet can take tasks that would take, in this case, a human developer coding around 30 minutes to do in just a matter of seconds. And this is very, very important for things like retrieval. When you're trying to do agentic search, you want to loop through a ton of different options. You want to make sure that you have the right context and that you're gathering the right information. And 3.5 Sonnet, the new one, is very, very good at this. Next slide. So now moving into what specifically we're thinking about when we do retrieval. Contextual retrieval is this term that we kind of published and pioneered in a blog post as of about 2 months ago. And that, of course, is what Arjun will be explaining more about shortly. But in order to actually enable contextual retrieval in a very economical and latency-sensitive way, you need to first start from the foundation, which is prompt caching. So prompt caching is an API feature which allows you to cache or save a previous prefix in your prompt so that you can then reuse that prefix in basically a fraction of the time and at a fraction of the cost later on. So this significantly reduces your processing time and your costs for any sort of repetitive tasks or prompts with very consistent elements at the starting block. For 3.5 Sonnet, this can reduce input costs by up to 90% and your time to first token by up to 80%. Next slide. So this is very helpful for a lot of those agentic workflows or tool use things. As you're doing agentic search, you might keep appending context back to the beginning of your prompt, and that can then just become cached and cached and cached as you keep going, and you'll save that processing time and you'll save the cost. And next slide. So if you want to learn more about this, because it does get a little bit tricky as you start to implement it, definitely check out some of our resources on our docs and in our cookbook. These are just Google search terms you can go use to find those resources. So now moving on to the bulk of how we actually think about the best ways to implement retrieval, which is this new technique called contextual retrieval. So we found that this actually reduces incorrect chunk retrieval rates by up to 67% compared to just traditional embedding methods. Next slide. How this works is basically when you look at a standard RAG procedure, you often destroy the context in the process of chunking up your documents for embedding. So you might have this document and you take 1024 character chunks and you just extract it right out of the document. But that creates this isolation problem where one chunk later on in the document might not have the references to information that were previously stated up above. Next slide. So we solve this with contextual retrieval by adding a relevant context to each chunk before we actually embed or index it. And to add this relevant context, we actually use Claude to generate chunk-specific explanatory context, which preserves this critical information. One way I like to frame this is that it's basically like studying all of your data before you go and index it. Next slide. Here is a quick diagram that I pulled out of our blog post on this for explaining how this kind of works. So you can see our corpus of information. We've selected out one file out of this corpus. We split it into chunks, just like you do traditionally. But now instead of going straight to the embedding step, we actually put Claude in the middle of this loop. So now we have Claude run through each one of these chunks in relation to the entire document, and then extract out the relevant information and append it into that chunk. So now each chunk has the actual information that you want to embed, plus the context of what might be missing from that data. And then we can put that through our embedding model, we can put that through our indexing models, and then put it into our vector database like Pinecone. Next slide. So let's take a practical look at what this actually looks like with a real life chunk. So maybe you have something very simple, you're analyzing financial statements, and you have this sentence, the company's revenue grew by 3% over the previous quarter. If you want to embed that, you're missing a lot of information, right? You don't know what the company is, you don't know what the previous quarter was, you don't know the date, the time. It's just a lot of things are missing to when you're doing that search later on, you won't be able to find the right pieces of information. Maybe within this document, there's multiple companies whose revenue grew by 3%. So we can use Claude to actually contextualize this chunk. We pass in that full document, we pass in the chunk, and then we say, okay, Claude, fill in this relevant information. And now you'll see that this chunk gets transformed into, this chunk is from Acme Corp's Q2 2023 SEC filing. Previous quarter revenue is this, revenue grew by 3% over the previous quarter. Next slide. So this is very, very powerful. As you might imagine, now we've added this context onto that chunk. This improves our search, this improves that retrieval. But the downside to this is that it is prohibitively expensive to implement because, of course, you need to call Claude and pass in your full document for each chunk. But tying back to prompt caching, this is why I started with this, prompt caching enables this to all be done in a very uniquely cost-effective way. So now what you can do is you can actually have that document at the top of your prompt. You cache that document on the first pass. And then for each chunk out of that document, you just append it to the end. So now you're only actually running Claude basically over each subsequent chunk instead of having to pass through the whole document each time. So with this, we've done some cost estimates, and then we've seen that for 3.5 Sonnet, your estimated cost for contextualization is only roughly about $1 per million document tokens. So it's very, very powerful at a very low cost and fast latency.
Awesome.
And now I'm going to
Thanks so
toss
much,
it back
Alex.
to Arjun. Yeah.
Awesome. Thanks so much. I'm going to quickly touch on how we're using AWS for the demo. We're using Bedrock and SageMaker notebooks. Bedrock is great for accessing the Claude API, and SageMaker provides a really clean environment for kind of doing a top-to-bottom educational example of how to do this approach. And we're using the Titan text embedding models as well, because we can then embed the text contextualized chunks, as Alex described, into Pinecone and our vector database. But what does this application actually look like? So I'll show you really quickly what we're going to build and what each step is, and then we'll walk over the notebook and mess around with the application that we've built to see the contextual retrieval in action. So first, we're going to talk about the pre-processing step. First, we have this video data, and we need to convert it to a format that makes it easy for Claude to do this initial contextual retrieval. So we're going to start with the video data, and we're going to extract the frames and the transcript from the video. So we're going to use a transcription engine to do this. We use Whisper, but of course you can use AWS Transcribe, and we'll cache the completed transcript. And we'll also write out all of the frames. Now, instead of having like video data, we have image and text data, but we are going to walk over the video in 45-second intervals, which allows us to kind of take a sample every 45 seconds of what is going on inside the video. And with the transcript, we're going to look at what words are being spoken and the timestamp on a word level. Then we'll just assign words to the frames inside of those 45-second intervals. And that'll give us these frame transcript pairs in addition to the whole complete transcript of the entire video, which we can then use for the Claude contextual retrieval workflow. Now that we have the frame word pairs and the transcript, we're going to pull out the frame as an image. We're going to take the raw transcript of the frame, and we're going to take the summary of the entire transcript that we can create with Claude, and we'll use all of this information to create the contextual description of what is happening on screen in addition to what is being spoken in the context of the entire video. Now, this is exactly what Alex was talking about prior, where you have some information, raw information in this case, which is just the transcript and the image, and we're contextualizing it with what is actually on screen in addition to what the entire video is about. We'll do this for every frame image pair, or for every frame transcript pair, and we'll yield a set of frame context pairs per video. These are going to be the text-only information that we're going to embed and put inside Pinecone. Now that we have these contextual frame pairs, we're going to create a bunch of metadata about the pairs, which will allow us to reference some important information that we're not necessarily embedding. For example, the raw transcript or the path to the images that we're storing locally. We'll use the Titan text embedding model to embed this contextual information to create context metadata vector pairs, which we will upsert into Pinecone. And this is what we're doing our vector semantic search over. Finally, once we've completed that workflow, we are ready to do the full retrieval augmented generation with one extra trick. So we'll have our input query, which gets embedded by the Titan text embedding model, and we'll query Pinecone with that. That'll yield a set of matches, which are going to contain the image context pairs as metadata. So the matches will be the contextual descriptions, but we'll be able to figure out what those full descriptions are and what image paths we should be looking at because of the metadata that's attached to them. From disk, we'll read in the frames that have been retrieved, and we'll pass that to a prompt builder. And we'll be able to pass the actual images and the contextual descriptions directly to Claude, which allows us to yet again leverage the visual question answering capabilities of the Claude LLM to create a final generated response in response to the input query. This is a pretty clever trick because it means we don't have to be uploading and downloading images all the time. We're just doing a text-only search and then referencing the images that are retrieved only as necessary for us to answer these questions in the first place. Awesome. Now that we've kind of spoken about our stack and what we want to do, I can kind of show you what the demo is going to look like. So I'll go ahead and share my screen and go up to the notebook so we can look at what is going on. So just a moment. Oh, just 1 second, a little bit of technical difficulties. We love Zoom. All right. Still having an issue, just a moment. There we go. Awesome. Can everybody see that?
Yes.
Great. Give me a moment to rearrange my Zoom really quickly, and we'll be ready to begin. Awesome. So this is our notebook. We're going to start. A lot of the computation in this notebook is pretty time consuming. So I'm not going to, for example, transcribe the video or create the contextual chunks live, but we will be able to do the querying live so we can kind of see what the results look like when we ask certain videos of what's going on. Before we get started, we're going to do some quick dependency cleanup. So I'll just walk over this, and we're going to start with the video preprocessing step. This is the idea that we're taking the frames, doing the transcription, and turning the video into frame transcript pairs. This is just a little bit of cleanup that we're doing, and we're going to walk over every single video in our video repository. We're going to create the transcript. We're going to extract the frames. We'll assign the words to the frames, and that'll yield a bunch of data on what frames are being extracted in addition to what words are being transcribed. Awesome. We use FFmpeg to kind of make this a lot easier. And like I said, we use Whisper to do the transcription, but you can use AWS Transcribe, of course, if that's something that's easier for you. In order for us to do the contextual retrieval, we have to pass the images and convert them in order to pass them to Claude. So we need this helper function here in order to take in the images and convert them to base 64 so Claude can interpret them. We use Claude Haiku because it's really fast and allows us to kind of quickly have that image text understanding. And we'll create a helper function here that allows us to kind of do one image, one piece of text, get a response back with Claude to kind of make it easy for us to pre-process each frame transcript pair. We'll write another helper function here to do the entire transcript summarization, and we'll be able to use that repeatedly as we're creating the contextual pairs. When we created this demo, prompt caching was not available on Bedrock, so we weren't able to leverage that capability. But of course, when you're working with your own demo, you can use prompt caching in order to save on cost a little bit. Now we're ready to do the contextual retrieval step. Again, this is the idea that we're going to take the frames as images, the transcript of what has happened inside of that 45-second frame. We're going to take the summary that we're using to transcribe the entire video and create that contextual description and frame context pairs. The easiest way to do this is to have this meta prompt and embed all of the information that we need in the prompt in order to yield the contextual description. So you can see that we're basically walking over each frame. We're going to take the summary of the video, pass that here. We're going to take the raw transcript, pass that in, and then we're going to prompt Claude to interpret what is on screen, what is being covered in the entire video, and what is being said in that snippet in order to create that contextual description. I've added a few extra lines here to kind of adjust for webinars where you might have two people talking on screen, or if there's a code snippet to do some extra explanation, or if there's an important diagram to do some extra explanation on that as well. And you might be wondering, where does the image actually play into this? Well, using our helper function, Ask Claude, we pass the image first, and then we pass this prompt for Claude to kind of do that response on after, and then we wait for the response to come back. So now that we have all of these functions that are ready together in order to kind of do this type of contextual description, we can iterate over all of the frames in the entire transcript in order to yield these new pairs, which will not only contain the contextual frame description, but they will also contain additional metadata, which is helpful for us when we query over this in Pinecone. The transcript summary, the time step of when this happened, the frame path, and the actual words that were spoken. And you can imagine that this can make for some interesting applications. For example, if your videos you're searching over on YouTube, you could use the timestamps to directly send a clip of that video to somebody once you've queried the database. And we'll write that out. You can see that we've kind of written out the summary of the entire video here. And this is what's going to be used in that meta prompt that I described prior. And like I said, we're doing this over the multilingual semantic search webinar that I presented earlier, which is why you're going to see a lot of text about multilingualism and embedding models. Okay, now we're in a place where we've already embedded the data, we've created these contextual pairs, we're ready to embed them and put them inside Pinecone. So we're going to use the AWS Bedrock Titan text embedding model to embed the contextual descriptions, and we're going to use Pinecone to store all of these vectors. And most importantly, we're not storing the raw images in Pinecone. We're just storing their metadata of where they're located inside this notebook in order for us to access them later. It's pretty easy to get started with the text embedding model. We create a helper function here to do the embeddings. We do the embeddings for the entire contextual frame descriptions, and we're going to yield a data frame that kind of looks something like this. And using the data frame, we can use an awesome function within the Pinecone library, upsert from data frame, to kind of handle all of this upsertion for us. We're going to create an index. We're going to specify the dimension size, which is going to be based on the text embedding model, and then we'll just upsert directly into there. Nice thing about upsert from data frame is that it handles rate limits for us, so we don't have to think too hard about the things that we're working with. The video that we're working with is about 45 minutes, and we're going over it in 45-second intervals, which is why we see about 72 vectors being generated. Finally, we need to set up a few more helper functions for us to do this visual RAG workflow. We want a way for us to directly ingest the response back from Pinecone to Claude. And that's what this function is going to do. It's going to take in the list of matches that Pinecone retrieves, read them all in, process them as images, create the meta prompt, and then pass that back to Claude. And again, this is the architecture that we're kind of going to be working with. We have our input query, we have the Titan text embedding model, and we kind of query everything that we kind of query, get our matches back, get the local frames, put that into the prompt builder, and generate our final response. All right, now let's try to put this for a test run. First question I'm going to ask is how much data does it really take to make a multilingual large language model? We're going to embed that using Titan, get a response using Pinecone, and get the Claude response using the matches from Pinecone in addition to the query text. Let's go ahead and run this. It'll take a few seconds for us to kind of retrieve this information in addition to generate the response. And great, we get a response about using the CC100 dataset, which refers to what XLMR uses to create a multilingual embedding model. Now, just having the response independently like this might not be as enlightening. So why don't we create a helper function to kind of help us understand what is being visualized when we are looking at the response that's being created. And you can see that we've retrieved a frame from the video, which has this graphic of the data that's being used in the video, in addition to all of the languages that are appearing and the actual data set that's being used. Now, I don't actually say CC100 while I'm talking about this in the video. This is something that Claude was able to pick up on just based on the image of the frame in screen. We also get the transcript information back so we can kind of see what I was trying to say, in addition to the contextual description. And this contextual description is great. We can see that it's a frame from a presentation on multilingual search technologies. The graph has to do with 88 different languages and the Wiki 100 corpus and the CC 100 corpus, so on and so forth. So this was a great retrieval hit. And you can see we're getting a few other frames back about the question we were asking, which is multilingual semantic search. Great. Now let's do some other more interesting queries. So I wrote this helper function to kind of make this a little faster. We're going to go through a few different query types in order to kind of show the different capabilities of the demo that we've created. At some point, I talked about Madlib for robots. What's this? Well, you might remember that I said that, but you not remember what it meant in context. So let's try to find what this was said and what is kind of meant here. We wait, we get the matches, we can print the response, we get a summary of what this means. It's based on the concept of masked language modeling, which is this idea that large language models use in order to drop some pieces of text and then try to predict what has occurred in those texts. We get the slide back when I say Madlibs for, or when it is being written on screen, Madlibs for robots, and also the transcript and the contextual description of when I'm actually trying to explain that. So that's a great hit. That ended up working really well. During the slideshow, I showed a screen where I was talking about cultural nuances and how that was a little dissonant from what was being presented. So let's see what happens when we do that search. So we get that slide back, which is impressive because this screen isn't talking about marriage cultural nuances. It is talking about when semantic search works and doesn't work. And we do get the section back when I was talking about the wedding specifically. So that is also impressive because we're handling something that wasn't really said on screen, but was spoken, which shows why we're able to kind of handle both of these modalities at the same time using this pre-processing technique. Let's try a query that has to do with interpreting diagrams. I asked Claude, there was a diagram on screen with a bunch of arrows and something about paired training. Can you explain this concept to me? This is a common thing that might happen during a webinar. You'll have a diagram that's kind of confusing. You might not remember what it was meant by it or what should you be doing with that information. Can you explain this? We can see that we get a hit on the weakly supervised contrastive pre-training diagram. It has a bunch of arrows. It's explaining this complicated paired training concept, and we get the contextual description back. Finally, Claude is able to kind of explain what this concept is based on the retrieved context, which is super useful. Okay, let's do something a little more challenging. At some point, I walk over a Jupyter notebook really similar to this one in that other video. So let's see if Claude can find that notebook and also give me a response on this question. I'm asking about cross-lingual and multilingual search and how I can kind of think about doing that with Pinecone through code blocks. So we can see we get a hit back on semantic search with Pinecone, so not super great. But at near the end here, near the top 5, we do get an embedding screen on the code that I did some of this semantic search with. And we do get a hit on the specific type of cross-lingual search that I was doing in the presentation. So that's awesome. So not only were we able to get the screens that were relevant, we were also able to get the code that was relevant, even though Claude is just like looking at a picture of that screen, right? So that's pretty wild. Okay, let's do one more, and we'll head over to our own Q&A. I'm going to ask a question that's a little more complicated, which is this idea around what kinds of data are used to fine-tune multilingual LLMs and what innovations researchers had to come up with in order to create E5, which was the specific embedding model that I used during the call. And we get that screen back of which we were talking about different kinds of data sets and their importances. And the interesting thing that Claude was able to do is that it was able to kind of describe what these boxes were on screen and why they matter in context. So when we get this response back, we are able to kind of talk about the data sets that existed in the chart that was presented near the end of that call. And there we have it. We've covered a lot of different capabilities that we're able to do because we took this simplified contextual retrieval approach of slicing up this video into image and text pairs in order to get the ability for us to use Pinecone and Claude to ask natural language questions over this data. Going to go back to the presentation now. Just a moment. Just a second. I can't seem to re-enable my screen sharing, so give me a moment to troubleshoot what is happening with the Zoom here. I'm unable to kind of click the buttons I need on screen, so give me a second to fix that, and we can get straight into the Q&A.
Arjun, I'm going to try sharing my screen because I think I have your deck. Let's see if I can.
Awesome, thank you. Sorry, my Zoom is just completely frozen. I'm unable to kind of hit the buttons I need to. Great, that's exactly where I was. Awesome. So now that you kind of have access to a really simple way of thinking about and doing contextual retrieval, what can you do with this information? We'll be releasing this demo publicly for people to kind of use and mess around with. You'll need SageMaker, Bedrock, and Cloud Access in order to run the notebook in addition to a Pinecone API key, but the API key you're able to get one just by signing up through our service. You could try to extend the demo to many different kinds of videos. We were just doing one in this one, or you can do a whole YouTube channel. You could add BM25 to do a full form of contextual retrieval like Alex was explaining prior. You could create a valuation set to kind of understand how well you're doing on retrieving the relevant sections of different kinds of videos based on the querying that you're doing. Or you could adjust the pre-processing parameters that we were using in order for more fine-grained control. For example, I was sampling at a rate of every 45 seconds, but you could go down or up depending on the amount of information that's being presented on each video that you're working with. And next slide, please, Bear. And that's it, everyone. Thank you so much for coming and listening to our presentation. We're happy to answer any questions that you might have about contextual retrieval using Pinecone or using Claude. So let's get into it.
I'm just gonna give a quick note to the audience because I've seen a handful of people use the raise hand feature inside Zoom. Since no one's microphones are enabled, please pop your questions in the Q&A box. And the same goes for, I tried to keep pace with a lot of folks who are asking questions in the chat, but some of you I did not get to. Please copy those questions over to Q&A and Alex and Arjun will be able to take a look now. Arjun and Alex, do you have access to the Q&A box? Do you want me to feed you some questions or do you just want to start going through?
Sorry, I can't click on the questions because my Zoom is frozen, so I can't quite see them. Would be happy to kind of get some fed, and then I will go ahead and help and answer.
Sure. Why don't I
Yes.
start with one that's for Alex? This is coming from Prito, which is
Great.
why is Claude more suitable for RAG compared to other models like ChatGPT, Gemini, or Llama 3? You touched on some of this in your presentation slides.
Yeah, I mean, I think there's a few aspects you have to consider here. This RAG, as analogous to any other task when you're evaluating LLMs, there's a lot of factors. Context length for RAG is, of course, a very important one. You want to be able to reason over a large amount of tokens within your context as you're getting these embeddings passed in, as you're passing in documents, whatever it may be. I believe that Claude, especially the new 3.5 Sonnet, is particularly good at that. Its context window right now is 200,000 tokens. In the future, we look to extend this even further. Also, there's these other factors that I mentioned around increased intelligence, agentic planning, long horizon. I think increasingly RAG is going to start more looking like a loop instead of just a single flow, to where you'll be actually interfacing with these LLMs, going back and forth so that they gather all the relevant information before providing their answer. And it's not just a single shot through. So there's a few different things. Just like with everything, I always encourage people to create evals beforehand and then test on the models. I am slightly biased as I say that Claude is the best at this, but I always tell devs, hey, try it for yourself on your own use case and come to your own conclusions there. Just scrolling through any of these other questions. Arjun, can you see these?
No, let me try to troubleshoot a bit so I can kind of look
Okay.
at them a little easier.
I see one. Are there any plans to allow prompt caching through AWS Bedrock? I saw that it's only currently available when using the Anthropic API directly. That's correct. It's currently not available on AWS Bedrock, but it's coming very soon. So yes, there are plans. I don't have a date, but we are working on it.
There was a question that came through the chat before about how if the embeddings that are, or sorry, the context that is relevant to the broader document are attached to every single chunk, do you run the risk of the chunks all getting the same embedding value or similar embedding values and this creating a problem for retrieval?
Awesome, I'm back.
Hey, Arjun. Alex, I think that was a question for you.
Oh, okay. Yeah, I think that's a valid concern, but I think the models are smart enough to differentiate between them. And this can also be done through prompting as well. So as you're setting up your prompt, and we specify the prompt in that blog post that we used, very, very simple. We just pass in the document. We say, here's a document, provide some relevant context to this chunk, and then we append the chunk. You can be a lot more clever with that as well. You can specify unique ways of how you want the information to be presented to keep it distinct. I would always run these things on just a few test cases first to make sure that you like your quality, hand grade your outputs, take a look at what those look like when you're embedding it. And then once you're satisfied with your quality, run it across all your documents in your corpus. So I think there's a lot of ways you can get clever, and kind of the cool thing about how we're using LLMs here is that they just allow for that generality and that steerability towards whichever contextual format you want. You're not really pinned down to anything in particular.
Getting access to the notebook, we'll be releasing it as a GitHub repo, so people will be able to kind of pull it down, use it. We'll probably add a little more functionality, kind of make it easier for people to use and modify. So don't worry about that. Alexis will make it easy for people to access.
How are you both
Eli,
doing?
this is a, oh,
Sorry.
what's up?
I was just wondering whether you all can see the Q&A now and whether you need me to keep moderating.
I can see the new questions, but not the historical ones.
Let's see.
Yes, the repo will be sent out via email. I'm seeing a few questions that are related directly to the demo. So Satish is asking about the workflow that we're kind of showing. So yes, this is roughly correct. What we're doing is we are converting the video into frame and text pairs, and then we're describing what is going on inside that frame with respect to the transcript, with respect to the entire transcript of the video. So what's being stored inside there is just inside the vector database is just the contextual description, not the images, because we are just doing the text-only search there. And then once we pass it to Claude at the end, we have the ability to pass Claude the images directly because Claude has this awesome visual question answering capability. So at the end, we pass Claude the images and the contextual pairs in addition to the query that's being asked. And we say, hey, with all this information that we're giving you, can you try to answer this query that the user has asked? That's how the LLM is able to do that type of summarization. John has a question about hybrid search and contextual retrieval. So one of the ways to do contextual retrieval, Alex, please correct me if I'm wrong, but you could incorporate something like TF-IDF or Best Match 25 in order to kind of get the benefits of keyword search in addition to Pinecone. So you should see a lift, an additional lift, because you're able to do that keyword search and you're able to do that semantic search. For this demo, I chose to keep it really simple and just show you what happens when you do contextual embeddings and how much that helps. But you, of course, could add, BM25, TF-IDF to kind of make that work a little easier. Anything to add to that, Alex?
Yeah, so if you check out our blog post, which I think somebody posted a link to in the chat earlier, if you just search contextual retrieval Anthropic, you'll find it. We do show how with each thing you add, you do get a improvement in your chunk retrieval rate. So when you do the full combination of contextual embeddings plus contextual BM25 or something like that, you do get the best of both worlds to some degree, and you get the semantic search, but also the keywords and everything else.
Keep these questions coming. They're really fun to answer. David, I see you. A little bit of heard you like video webinars. Let me throw that webinar inside your webinar. Yeah, I think it'd be really fun to throw this webinar at this type of application and see what would kind of go on. It would totally work. Talha, you had a question about the segmenting that we're doing. Why 45 seconds? Honestly, this was just a parameter that I picked just messing around with using the demo. If you pick a window that's too small, there isn't enough spoken text in order to create a helpful description. If you pick a window that's too big, there might be too many slides that have been flipped through and you're only taking one snapshot within that. So I just chose 45 seconds because that kind of correlated with that pipeline of with that rate in which I was speaking in that video. But of course, you can kind of adjust this per video. You could adjust this based on the videos that you're working with to kind of make this easier to use. Jeffrey has a question on cached prompt caching. Alex, do you think you could attack this? It looks like it's about when the cache prompt is being sent at inference time and how it's actually beneficial there.
Yeah, so I can't dive too much into like the actual implementation details, but we can think about is just at a high level. An LLM is this autoregressive model that has to go back and check every single word for each subsequent word. And when it does that, at each point along the way, it's computing this KV cache. It's basically like a numerical matrix. And instead of having to recompute that every single time, we can just kind of checkpoint it at the end of our cache, where our cache breakpoint is. And then we don't need to go recompute after everything else. We just go from that point forward. So that's how that works at inference time at a very, very high level.
Have you tried this technique over, Indresh is asking, have you tried this technique over tens of thousands of documents? Our customers have this huge document base. I'm curious about how this technique holds. Alex, you want to talk about this with respect to contextual retrieval and kind of like scaling costs and what that looks like?
Yeah, I mean, I think the reason we developed this was primarily to target these large corpuses of documents. It is something that, of course, you're going to need to do some plumbing on your end to like make sure it works as you do this pre-processing. But what's great about this technique is contextual retrieval, and just like all the embedding stuff to some degree, as long as the information is static and not changing too much, it's a one-time cost. So you just need to run your data through once, then you have these all embedded. And then you can do the actual retrieval stuff later on. But yeah, this scales to X number of documents, just as it would if you're doing over 10 documents.
Eli has an interesting question about basically re-ranking. So Eli is asking, how do you think about the trade-off between throwing a long tail of retrieved Pinecone results at Claude 3.5 versus trimming down to the most relevant, especially when it's hard to know which results will have the answer to the user's request? In my usage so far, I've seen answer quality diminish quickly above 40 retrieved embeddings. So maybe we'll do like a tag team answer on this, Alex. So I'll talk about kind of re-ranking and how that's helpful. And Alex, maybe you can talk about like Claude's long context ability and how it can deal with kind of throwing tons of things there. So with respect to this, like it's important to kind of re-rank the data that's being retrieved when you kind of get some responses here. We lucked out here where when we were doing this re-ranking, we didn't have to, when we were doing this type of generation, we didn't have to do too much messing around here. But you're right that ideally you want to optimize the amount of information that's being sent so that there isn't too much irrelevant context there. But I think Alex can speak to how well Claude can deal with huge contexts, especially given the 200K context window the models can kind of deal with.
Yeah. So definitely there is with everything long context, a balance and a trade-off that you have to factor in. With Claude, usually that trade-off is in your favor because you can't just keep throwing information at it. And 200,000 tokens, 150,000 words, 160,000 words, that's a lot of information. Now the trade-off here is you're going to bump up your costs and you're going to bump up your latency. And there might be marginal intelligence decreases as well as you get to the max of that context window. Now, for the first two, prompt caching helps tremendously, right? So if you can utilize prompt caching as you have information, it's a little tough in a retrieval case where information might be inserted dynamically, but there are certain clever ways you can get around that. Then that helps with those first two. In the intelligence front, that's something we are working on. We think Claude is already industry leading for the ability to recall over its long context, as evidenced by tests like the needle in the haystack test, which you might have seen with all those green dots on a grid. But there's a lot of improvement still to be done. So we're continuing to work on just how Claude can reason over the entirety of its context window.
Awesome. A few more sorted questions. John is asking, when will we get the repo? Very soon, along with the webinar recording. Do we need to use LangChain for any of this? Not necessarily. If you're using another framework to kind of orchestrate your LLM calls, you can do that. You don't have to do that. I didn't use LangChain in this demo, so it's not needed. Vinod is asking about what the recommended way to re-rank is. It depends on the data that you're working with and the re-ranker model that you're working with. Pinecone has a re-ranker that is text only. And what's nice with this workflow is that the retrieved results are text only. So you could just throw the re-ranker at that. Typically, you want to increase the top K that you're kind of passing. So you might do top K of like 10 to 20 or maybe even 30. And then you re-rank down back to 5. So you're passing as many relevant results as possible that could be relevant. You use the re-ranker to get the most relevant results and move forward from there.